So when you first press the button, okay, you get 50 particles releasing. So there's your 50, okay? Now, you can also go in here and adjust the light particles as well, but right now we're only looking at one set of particles, unless it tells us to do something different, okay? All right, so it says, we're gonna skip the last sentence because it doesn't mean anything. Choose the laws option on the right. So right now we are in intro, right? This is intro. So we actually need to go back out of this. We need to go back. And we need to go back to the gases intro. And this time when we click on this, we're going to go to the laws section this time. Okay, so click on the laws, or double click on it. All right. So we're going to go ahead and spray it in there. And the particles are right here. See where the little green plus sign is? If you click on that, it'll tell you it's back to 50 again, okay? All right. So it says choose the laws option on the right, which we did. See the picture. Experiment 1, volume. Give 1 pump of gas into the chamber. Give 1 pump of gas into the chamber. Choose to hold the volume constant by selecting that option in the upper right-hand corner. See the picture. The picture it's talking about is this one right here. Okay? That's what your box looks like. And it is talking about this box right here. So we're going to click that box. Okay? We're going to click volume. Okay. All right. Now it says, what is the initial temperature in K and pressure in ATM in the chamber? The initial pressure is 5.8 atmospheres. So that's no different than the previous experiment. And 300 Kelvin, that's also no different. Okay. And you can, if you want to, you can go ahead and click these boxes as well. That just gives you all those other options that you might use later. So 300 Kelvin is going to be our initial temperature. So where it says, what is our initial temperature? 300 Kelvin. Okay. And it says, and the pressure in atmospheres. The pressure in atmospheres is going to be 5.8 ATM. Okay. So that is the answer to this question right here. Okay. Do you guys see how I'm literally just reading through this and adjusting the computer? Or you can do this on your phone too, I think. I think it runs on your phone as well. Can anybody tell me that whether or not, have you tried it on your phone yet? Does it work on your phone or does it only work on computer? I think it's HTML5, so it should work on your phone too. It's probably a lot more fun to do on the phone. Anybody know? It works on your phone. Okay, cool. That's awesome. That's awesome. Well, we're going to be doing a lot more of these simulations because we can't be in the lab. And unfortunately, I don't have access to any of my lab stuff right now because I'm locked out of school just like everybody else. So it's not like I can go up there and grab a bunch of lab stuff and come back home and do labs at home. I don't have the facilities here to do that. I do have some lab equipment at home from previous work that I've done at other places, but not here. I don't have any chemical at home. And I'm not bringing it home because I have a 6-year-old and she'll get into it. So this is about as close as we get to a lab right now, unfortunately. All right. So it says number 3, it says use the slider at the bottom of the simulator to add heat and double the temperature. So what's our temperature right now? Our temperature is 300 Kelvin. So you're going to look down here and we're actually going to increase the heat. Whoops. We're going to increase the heat. Man, you don't want to work, do you? Okay, you see it going up. We're going to go up to 600, thereabouts. 608. This is not the easiest to do this. And this is also not how real lab works either. You don't have a heat source that puts out exact temperatures. All right, so 600 Kelvin, okay? Now, what does it say? It says we doubled the temperature, add heat. Did the pressure go up or down? The pressure is reading at 11.7 atmospheres. And where was it initially? At 5.8. It makes sense that the pressure goes up. So we would say pressure increases. Just draw a little up arrow. And then it says, what is the new pressure in the chamber? We're going to put a comma or a semicolon here. And it moved to 11.7 atmospheres. Okay? I actually think this is kind of fun to do this. I think this is a really cool program. And I haven't used it since I was in my master's program in 2012. So it was 8 years ago. But yeah, this is pretty cool. So if you get a chance to actually play around this beyond the homework that you're doing, I think that you'll probably learn a lot. Okay? All right, so it says keeping the volume constant and the number of particles constant. Okay? So basically what that means is we're not changing the size of the box, and the number of particles is going to stay at 50. Okay? So we go back here. It says change the temperature and record the pressure, which we just did change the temperature. I'll repeat this 4 times. Okay. So basically what you're doing is we already have 2 of these though, right? We have 300K and we have 5.8. Yeah, I didn't have this 20 years ago either. It would have made learning chemistry at Texas Tech significantly easier. That's what I tell my kids all the time at school is we didn't even have Google 20 years ago. Yahoo was about as close as you were going to get to a search engine, and it was terrible. Ask Jeeves, yeah, there's another one. So it's kind of hard for them to even understand that because even back then, we had just gotten phones. So prior to that, I actually got my beeper taken up at school because I have my beeper out. So when I get on you guys about your cell phones in class, just imagine that, right? Y'all probably don't know what a beeper looks like. I doubt it. Be shocked. Unless you watch a lot of like ER or something. All right, so 300 Kelvin is 5.8 atmospheres, okay? And we doubled the temperature, right? We said we doubled the temperature, which means we went from 300 to 600. So let's just put 600 down at the bottom. We won't go any higher than 600. And our pressure came out to 11.7 atmospheres, okay? And I'm getting that information from right here. So we doubled the temperature from 300K to 600K by using the little bucket down here, okay? And then right here, our pressure gauge went from 5.8 to 11.7, okay? All right, so what we're going to do now, we're just going to adjust the temperature to continue filling out this box. So let's just put values in there. Let's say 400, let's say 475, and let's say 550. Okay? So what you would need to do at that point then is go ahead and adjust the temperature and then find out what those pressures are. Okay? Describe the graph and relationship. So what is a relationship? We don't need all these other values to tell us, do we? Okay? We can just look here and here. As the temperature increases, the pressure increases as well. Okay? And that is actually what we call Gay-Lussac law. We say that there is a directly proportional relationship between temperature and pressure. That equation actually looks like this. So if you go back and look at some of the previous videos I did, that was the equation that we used for Gay-Lussac. So as my temperature increases, my pressure increases. You're not going to be able to increase your pressure unless you adjust your volume if you keep your temperature constant. Okay? Pressure doesn't change by itself. It requires something else to cause it to change. So you're either going to be decreasing or increasing the volume while keeping the temperature constant, or increasing or decreasing the temperature while keeping the volume or the size of the container constant. Okay? And that will give you a different pressure value. All right. So what is it says describe the relationship in the graph. So if we're to do a graph of this, right? If we're to do a graph of this, we're going to put our temperature, is going to be on the y-axis, and our pressure is going to be on the x-axis, okay? So we would say down here, we might say this is 300, this is 400, 500, 600, and our temperature is in Kelvin. Okay, and then our pressure is down here in ATM. So we might do anywhere from 5.8 to 11.7, somewhere in there. So you would just go through and do some even values of some sort and make sure that it looks nice. Okay, so you might say like 5.5, 6.5, 7.5, 8.5, 9.5, 10.5, 11.5, and then 12.5, because the highest we're going to go is 11.7. Okay. Now, that's a really quick graph. You could do it on Google Sheets, or you could actually just go ahead and use graph paper and do it that way, or you could just make your own graph, okay? All I am looking for is to see that it does this right here. That's it. As a directly proportional line. Directly proportional. Proportional. Can't spell today. Okay, directly proportional. So what that means is that as my pressure is increasing, my temperature is increasing as well. Actually, I said that backwards. As my temperature increases, my pressure will increase as well. Okay? Okay. All right, experiment 2, this is temperature. This is no different than the previous one. Okay, and I'm approaching 35 minutes on a video here, which means I've got to stop the video because I'm not going to be able to upload this to YouTube for let it go much longer. All right, so the rest of this packet, you guys should be able to answer, okay? And I don't think you're going to have any problems with it. I think initially you guys are probably just scared of it because it was thick and it had a lot of questions in there and it had a lot of directions. But I think that you guys can do it now that I've kind of explained it. I'm going to upload this video onto YouTube so you guys can actually go back and relook at it if you have questions. There are also YouTube videos out there on exactly how to run this thing. And we didn't even get to a lot of the real nitty-gritty stuff in here that we might have used for, say, AP Chemistry, okay? Because this is a general chemistry class, so I'm trying to take it easy on you, right? Okay, so this will be a lab grade for you, okay? You need to take all the pictures of this and then go ahead and upload that into Classroom. So when you guys go back to Classroom, you are going to upload your pictures, or we're going to go to View Assignment right here. View the assignment. And I can't see it, but this is what your screen will look like right here, okay? So down here on the bottom, it'll say something like add or upload or whatever. That's where you're going to upload your information. So you need to take a picture of every single one of the pages on there, okay? Or your work. If you want to type it out, you can do that. That might be a little bit easier for you, so that way you can go ahead and just turn that in as like a Google Doc. But either way, get that turned in. You guys have any more questions for me before I stop the stream and call it a day? I hope that this was helpful for you. So if you guys are a 1 out of 5, where are you at right now with it? 1 being I don't understand what we're doing, and a 5 being I'm great. Where are you guys at 1 through 5? Five, good, good. And it's okay not to be perfect right now. You guys are going to be all right. Cinco, I'm glad I know Spanish. That's good. Bye. Have a good day. We're good. Good. All right, 3. All right. You joined a little bit later, too. You need to see it done and make sure you're doing it right. Good. And a 5. Thank you. Okay, guys. If y'all have anything else, all right, my email address is right here on the assignment on Classroom, okay? So feel free to email me, or you can DM me on IG. I would prefer that you email me, though, okay? And in fact, I will probably tell you to go ahead and email me with your questions as opposed to IMing me, okay? Or DMing me on IG, all right? You guys have a blessed day. Have a great weekend. And thanks for coming this morning. I appreciate it. We'll talk to you guys later.